Okay, so moving on to number 21 on packet 5. This looks like the limit definition of a derivative. And if you guys forgot, which most students tend to do, the definition is, I'll say f prime of x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, the idea here is, so you kind of have to recognize, well, what is f of x plus h and what is f of x, right? Now, if you notice, like if I stopped or if I section this off here, here's a parentheses here, and then this section this guy off here, kind of like that, what I'm doing right here. It looks like f of x is going to be, now remember, there's a minus right here, right? So essentially that's going to be f of x, oops, let's use like f of x is going to equal 2x to the fifth minus 5x cubed, right? They already distribute that negative to here, made it a positive, right? And if that's true, just to do a quick check, if this is your f of x, well, what's f of x plus h? Well, that's simply replacing x plus h for x. So I have 2 times x plus h to the fifth power minus 5 x plus h to the third power. And great, because this is exactly this. So we've chosen correctly, or you figured out what f of x is, right? Now, so if this is my definition derivative, my limit definition of derivative, the question is asking for what is f prime of x? Well, if f of x is here, we just simply have to take the derivative, which is what, 10x to the fourth minus 15x squared, right? And that looks like choice D. Okay. My next question is going to be number 22. This looks like a question about those properties of definite integrals kind of thing. If they're looking for they're looking for integration from 8 to 4. They gave you all this other information, so you got to come up with this. Now, you have stuff from like 2 to 8, integration of 2 to 8, and you have integration from 2 to 4. You're looking for 8 to 4. Let me write something general about integration from 2 to 8, right? If I take my integration from 2 to 4, and let's put f of x dx, and if I add the integration, going to step up from 4 to 8, f of x dx, well, you're going to get like the total from 2 all the way to 8 of f of x dx. So this is the general form that I'm going to use, that I chose to use. You can come up with something your own, but I'm going to use this. So what's nice about that is I have, here is from 2 to 4, which means it's matching this over here. You don't really see that. That's fine. We can't really see that. And then I have 2 to 8, which is, you're probably not going to be able to see much of that. Yeah, kind of weird. Okay, so I'm going to substitute that in for, I get a 6 here plus, I don't know this. I mean, I'm kind of looking for it, but you know, my bounds are switched, and we'll talk about that very shortly. And then so I have from 2 to 8, that's going to be negative 10. Okay, so if I add 6 to both sides, all right, I'm going to get, let's see, no, not add 6. I knew something was wrong. I meant subtract 6, right? Subtract 6, subtract 6. Okay. I have integration from 4 to 8 of f of x dx equals to, okay, so that's a negative 16. Now, the question's asking for from 8 to 4. I have a solution for 4 to 8, but we could switch these two bounds as long as you multiply by negative or include a negative. So I can switch this or rewrite this as a negative, switching bounds f of x dx, which means, well, I'm going to multiply this by negative, so I get a positive 16. And so it looks like my answer is E. And you notice negative 16 is right here, which is really tricky, right? Because most students might think it's negative 16, but the answer is actually positive 16. Okay. Okay, so continue on for number 23. If the graph of this has a point of inflection at 2, 0, what's the value of B? Okay, so point of inflection sounds like we got to find y double prime, right? The second derivative. So I'm going to start, well, let me copy the problem down. I have x cubed plus ax squared plus bx minus 8. And I'm going to do the first derivative, y prime, which is 3x squared plus 2ax and plus b. Remember doing this in terms of x. And then one more, second derivative, because we're talking about point of inflection. So I get 6x plus 2a. A is just my constant. And luckily nice, the b is going to be 0. So my second derivative is just 6x plus 2a. Now, point of inflection indicates we have a critical number, right? Set equal to 0 and solve for x. And if they told me it has a point of inflection at 2, 0, well, let me just solve this part here. So at 2, 0, I'm going to input x for 2. So this will be 6 times 2 plus 2. I don't know a, so let's go like that. And then, well, okay, well, now I could solve for a. Here, you're going to get a equals to, I believe, negative 6. Oops. Okay, so a equals negative 6. So I can use in my original equation and the fact that, well, I have a point where the point of inflection lies, 2, 0. So my original equation, y, instead of x cubed, I could put 2 cubed plus I have my a value, negative 6, and my x value, 2 squared plus b times 2 minus 8. And I forgot to input my y value, right? So let me change out my y value is 0. And so here we could definitely solve for b, right? And if I solve that, b, I believe is 12. Okay, so it looks like my answer is going to be B. Okay, moving on to 24. If f of x is x and negative 1/3, what is the derivative of the inverse? So we got to find the derivative. We got to find the inverse of f of x first, right? And then we're going to go back. I think I squeeze it on the right side over here. If f of x equals x negative 1/3, well, I'm going to change this f of x to y, something you probably learned in Algebra 1 or Algebra 2. And then to find the inverse, we're going to switch our x and y's. So literally, I just wrote x now, and now it's y to negative 1/3. And then we're going to solve for y to find the inverse. To get rid of that negative 1/3 power, I'm just going to take the negative 1/3 power to both sides or on both sides. And it looks like I get x to the negative 1/3 equals to y. So this is my inverse. And if I want the derivative, well, we just take y prime, given the fact this is my inverse, negative 3x, negative 3 minus 1, so I get negative 4. And that's my derivative of the inverse. So that looks like choice answer E. Okay. Okay, so 25. If f is continuous on a closed interval between a and b, okay, it's continuous on a closed interval. That's all they're telling me. Which of the following statements is not necessarily true? Okay, so right off the bat, number 1 and number 2, f has a minimum and a maximum on the closed interval a and b, as long as it's continuous, which it is, right? They put continuous function here. Thinking about the extreme value theorem, you have to have a maximum. You have to have a minimum, at least a maximum, at least one minimum, one maximum between the closed interval. So 1 and 2 is definitely true just on the extreme value theorem. So I'm going to cancel these guys out because they are definitely true. We're looking for what's not necessarily true. Number 3, f prime of c equals 0 for a For a value of c between a and b, that sounds like, I believe, Rolle's theorem. Remember, it's like MVT, right? That's only true as long as they gave us something like f of a equals to f of b, which they did not, right? They only said continuous on the closed interval. That's the only only information about f they gave us. So this is not necessarily true, which means I don't have to have a slope of 0 for any value between a and b. So just for another quick example, let's say if I need to draw a continuous function on the closed interval from a to b, great. There's my continuous function from a to b. There's not a horizontal tangent anywhere between a and b. So 3 is not necessarily true. And that answer choice looks like C. Okay. Okay, moving on to 26. We've got the graph of y equals x over 1 minus absolute value of x has combination horizontal asymptote, vertical asymptote. We're trying to figure out how many of each. So let's first talk about, I think vertical asymptotes are easier to see, right? You have the bottom one, and it's a denominator, so we're kind of seeing like, well, where does my denominator become undefined, right? If it's undefined, that's going to create a vertical asymptote. So I'm going to do something like 1 minus absolute value of x and set it equal to 0 and find out where, because I can't have a 0 in my denominator, right? So where does that occur? Well, it looks like if x equals to -1 and +1, I'm going to get that 0. So these are going to be my vertical asymptote, my VA. So I'm going to have 2. And I'm going to have to pause just for a second here. Okay, sorry for an interruption. Once again, my vertical asymptote, I have 2 of them, which is nice, which means I can eliminate A, B, and C because they all say 1 vertical. Now, D and E, there's 2 verticals, great, but there's either 1 or 2 horizontal, so I still need to deal with figuring out the horizontal asymptote, right? Now, horizontal asymptote, we're going to take the limit as x approaches infinity and the limit as x approaches negative infinity. Okay, so if we look at what we're taking of, I'm taking of x over 1 minus absolute value x, and to negative infinity, okay, well, yeah, the same equation, 1 minus absolute value of x. Now you notice that both of these on the bottom here, they're the same, right? Whether you plug in or whether you substitute or plug in whatever, a very large positive or negative number, that absolute value makes it positive. So you're going to get the same value there. And on the bottom, you're going to get a negative value for both, regardless of what you substitute and what you plug in, right? Because a 1 minus some huge number is going to be a negative number. Now on the top here, obviously the first one here, this one's going to a very large positive number, and this one's going to a very large negative number. Now, thinking about if you're going to a very large positive number over a very large negative number, right? You can kind of say that this approaches -1. And then for the second example, if you're going to a very large negative number and a very large, over a very large negative number, you could simplify that to a +1. So it looks like I got 2 horizontal asymptotes. You have one at y equals -1, another at y equals +1. So it looks like my answer is going to be E. Okay. Okay. Okay, so moving on to 27 and 28. Number 27, volume of a cube. Okay, increasing at a rate, so you're given dv dt, right? That's good, right? dv dt equals 20. How fast in square meters per second is the surface area? Okay, increasing at the instant when each edge of the cube is 10. So we're going to call the edge of the cube x. You can call it s, whatever you want. We'll call it x. So dv dt equals to 20, x equals 10. This is given to us. And then we need to find the surface area. When is the surface area of the cube increasing? Okay, so I need to find ds dt. Find it when x equals 10. Okay, not too bad. So my surface area of a cube, surface area is simply going to be 6x squared. That's the area of one face times 6, because there's 6 faces, right? That's the total surface area. And then the volume of a cube is simply going to be x cubed, length times width times base, or length times width times height, right? X cubed, so they're all x's. And okay, so I'm going to do some substitution here. Looks like I don't want to take the derivative right now because I'm gonna end up with a dx dt, which I have no information about. That's not what I'm looking for. I'm looking for a dx dt. So I don't want dx dt coming up anywhere. So I definitely don't want to take the derivative right now. But there is a relationship between these two guys, right? I definitely have a dv dt, and I need to find ds dt. So I'm going to solve for x here. X equals to v to the 1/3 power. And then let's substitute that x in for v, right? So s equals 6 times v, and then you have this 1/3 quantity squared, which is 6v to the 2/3 power. That's good, right? So this is my s. Now I can take the derivative, and I don't have any dx dt's anywhere. Perfect. So if I take the derivative of both sides here, and I'm going to take it with respects to t, time. So I have ds dt equals to, I have a constant 6, and then I have v, this will be times 2/3, v, and then 2/3 minus 1, which is negative 1/3, and then times your dv dt. So there's my derivative. Now I'm looking for ds dt, my volume. Okay, so I need to figure out also with the volume. Hold on a second. Let's see. Okay, so I'm going to simplify this. Now let's bring it up over here. We got 12 divided by 3, which is 4. And here's a little trick with this guy right here. I guess I'll use blue to circle it. Can you guys see that? Yeah. V to the negative 1/3 power. And if you notice that x equals to v to the positive 1/3 power. So can I write this? Can I say that v to the negative 1/3 power would simply be 1 over x, right? I'm flipping both sides of the equation, right? So I'm going to replace this v to the 1/3 power with 1 over x. Why? Because I have x equals 10. I get to use that. I don't have v, right? So I'm going to change it back in terms of x, right? And so now I have this, let me put it white. So I have 4 times 1 over x, and then dv dt, well, that's given to us at 20 times 20. That's your ds dt, right? And then furthermore, x equals to 10. Okay, so now I have 4 times 1 over 10 times 20. That's going to give me my ds dt. So simplifying all this, I believe 8 is my ds dt, which is choice E. So the trick with this problem, and it is a really tricky problem, is that you're going to change. If I take this derivative straight out right now, I'm going to end up with a dx dt. So I replace this x with a v, took the derivative, I don't have any dx dt, but then once you have the derivative, I don't have a v now, I have an x. So change it back to x. So I can use this x equals 10 stuff, right? That's pretty challenging, right? Okay, so I got to set up the next problem. Okay, so 28, dy over dx, the derivative of y with respect to x equals x over y. They gave us y3 equals to 4. And essentially this translates, this is the same thing as like your 0.3 comma 4, okay? And so this original problem looks like a separation of variables, right? So I'm going to have to multiply both sides by y here. And at the same time, I'm going to multiply by dx. So on my left side, I get these cancel out, these cancel out. So now I have this y dy equals x dx. Well, that's kind of nice. So if I integrate both sides, I'm going to get y2 over 2, well, I don't need dy, equals to x2 over 2, and then I'll have this plus c. You can get rid of your 2's now, like so. And then I'm going to get y squared equals x squared. And this is a 2c, but it's just another constant. So let's just put a c. And then from here, I'm going to substitute 3 comma 4. So I have 4 squared equals 3 squared plus c. It looks like I get 16 equals to 9 plus c. So it looks like c we get a -7. So let's see what they're asking for us. Oh no, they're not asking anything. I think I have, let's see. Oh, so I have y squared equals to x squared plus 7, which is none of the answers. They all have this y squared minus or x squared minus. So let me just move this guy. Negative x squared, both sides. So y squared minus x squared equals to 7. Okay, so that looks like answer choice. What is it? Ugh. X squared minus 1. Ooh, that's kind of tricky. Looking at this guy right there. They decided to change everything in terms of, or multiply everything by -1. That's fine. So x squared minus y squared equals to -7. And that's answer choice A. Alrighty.